Okay, good morning students. In previous class, under the chapter Microbes in Human Welfare, we studied about the microbes in the production of chemicals, enzymes and other bioactive molecules. So in today's class, in present class, we are going to study microbes in sewage treatment. Microbes in sewage treatment. Now, before going to study this, I think you all have heard about the word sewage, and we know that a large quantity of wastewater are generated every day from the cities and towns, and the majority of component of this wastewater, whatever the wastewater is generated from the town and the cities every day, and in that what we are going to call it as a wastewater, the major component is what we are going to call it as a human excreta, and also the municipal waste, also one of the component of the wastewater, in the sense what we are going to call it as a municipal water, it is also the sewage. In the sense, sewage, it is the wastewater and that contain majority of a human excreta, and then I can say municipal wastewater is also considered as a sewage. It is also considered as a sewage. And when we are going to discuss about the sewage or a sewage water, that time this sewage is consists of large amount of organic matter and microbes. Large amount of organic matter and microbes. Here, you listen me carefully. Few points I am not able to write on the board. I will and books right? Okay, what I am telling you, sewage, in the sense, you all know every day there means the wastewater is generated, means wastewater is generated every day from the cities and towns, and major component of this wastewater, we are going to call it as a human excreta. Municipal wastewater is also considered as a sewage. In the sense, sewage is nothing but what the waste water, it is coming out from the household, or it is including the human excreta, or it is coming out from the municipal waste station, etc. And that water or that sewage consists of large amount of organic matter and microbes. Large amount of organic matter and microbes, and these large amount of organic matter and microbes are pathogens. And you all know about the pathogens. What is meant by pathogens? Pathogens are the disease causing organisms. Understood? Now what is going to happen here in the sense, this sewage water or the waste water, we couldn't, what we are going to call it as a dispose directly into the, what we are going to call that as, in a sense, natural water bodies. What are the natural water bodies? In the sense, river, sea or ponds, etc. Usually we sewage water directly directly now sewage water river or pond or sea water already I told you, this sewage water consists of large amount of organic matter and microbes. Those are the pathogens. Pathogens are the disease causing organism. These are not only the pathogens for the human beings. Now human beings are the pathogens. These are pathogenic for other aquatic organisms also. For example, fishes irಬಹುದು, frog, population natural water reservoirs. For example, rivers, then sea, ponds, okay, lakes, etc. So all it cause the pollution. It cause the pollution for those natural water bodies. Understood? So before that, what we are going to go for? We are going to go for means we used to treat that sewage. We used to give a treatment for that sewage. That is what we are going to call it as a means. For that, we are going to use the microbes. We are going to use the microbes. And before disposal of this sewage into the natural water bodies, before disposal of these sewage in a natural water bodies, the sewage is treated in a sewage treatment plant. Sewage is treated in a sewage treatment plant. STP in the sense sewage treatment plant. Okay, and that can make less pollution for the what we are going to call them as a natural reservoirs of water. Understood? So before you are going to water into the natural means water bodies like lake or river or seas, we used to what we call it as a sewage is treated in a sewage treatment plant. Sewage is treated in a sewage treatment plant. Now, how we are going to go for treating, in the sense treatment of this water. Second idea here, treatment of wastewater is done by heterotrophic microbes. Sewage water, in the sense treatment of this wastewater is done by heterotrophic microbes. Heterotrophic microbes in the sense the microbes which are grow on other microbes, means they use the food as other microbes or organic matter. Understood? And here what I have done, heterotrophic microbes which are present in the sewage, which are present already in the sewage. It is carried out in a two step. In the sense, what I told you, the sewage water, it is consist of large amount of organic matter and microbes. That those are pathogenic. So we are not going to release that sewage directly into the water bodies. Before that, the sewage is treated with the what I told you, sewage treatment plant, treated in a sewage treatment plant. And next, the treatment of sewage water is done by using the heterotrophic microbes. Heterotrophic microbes which are already present in the sewage. And how this can carry it out, in the sense the sewage water treatment is carried out in a two steps. What are those two stages? Or two steps. First one is primary treatment. First one is primary treatment. How we are going to do the primary treatment, in the sense easily you are going to remember a few things. In the sense, in a primary treatment, the sewage, from the sewage we are going to remove the physical particles, whether that is small particles or a large particle, and there also we are going to use two stages. In the sense, we used to remove first the floating ಅಂದ್ರೆ ಏನ ನೀರಿನ ತೇಲಾಡುವಂತ ಇದು ಒಂದು ಏನಪ್ಪಾ ಸಾಲಿಡ್ ಮಟೀರಿಯಲ್ ಅವು ನಾವು ರಿಮೂವ್ ಮಾಡ್ತೀವಿ. Then we are going to go for the removal of what sedimenting in the sense ಅದರೊಳಗೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ನೀರಿನ ಕೆಳಗಡೆ ಹೋಗಿ ನಾವು ತಳಕ್ಕೆ ಏನು ತಂದಾಗ ಅದನ್ನೆಲ್ಲ ಮಟ್ಟದ ಕೂತಿರ್ತಿಲ್ಲ ಅದನ್ನ ರಿಮೂವ್ ಮಾಡೋದು. Understood? So this is carried out in a primary treatment. So I written here on the board, primary treatment, what we are going to do in a primary treatment with the sewage water, in the sense physical removal of a particles from the sewage, large and small. Physical removal of a particles from a sewage, large and small, through filtration and sedimentation. Through the filtration and sedimentation. In filtration and sedimentation, what we are going to remove from the sewage, in the sense ಏನು ನಾವು ಅದರಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕು ಅಂದಾಗ, through the filtration we are going to remove the floating debris. Floating debris ಅಂದಾಗ ಮ್ಯಾಲೆ ಕೆಳಗಿರಲ್ಲ ಅವನ್ನೆಲ್ಲ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಪ್ರೈಮರಿ ಟ್ರೀಟ್ಮೆಂಟ್ ನಾಗ ರಿಮೂವ್ ಮಾಡ್ತೀವಿ ವಾಟರ್ ದಾಗಿಂದ with the help of filtration. And we are going to remove the grit, grit in the sense soil and small pebbles, some color soil ಅದ ಏನು ತಳಕ್ಕೆ ಹೋಗಿ ಹೋಗ್ತಿರ್ತೈತಿ, that we are going to remove with the help of sedimentation. That we are going to remove with the help of sedimentation. ಈಗ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ರಿ, ನಾವು ಒಂದು ಸಿವೇಜ್ ವಾಟರ್ ಇದೆ, ಸಿವೇಜ್ ವಾಟರ್ ಏನು ನಾವು ಫ್ಲೋಟಿಂಗ್ ಡೆಬ್ರಿಸ್ ತಗೊಂಡು ಅನಂತರ ಕೆಳಗಡೆ ಮಣ್ಣು ಮತ್ತು ಸ್ಮಾಲ್ ಪೆಬಲ್ಸ್ ಅಂತಂದ್ರೆ ನಮ್ಮ ಸಣ್ಣ ಹಳ್ಳ ತರಗತಿಗೆ ಸಾಲಿಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಂತ ಅವನು ರಿಮೂವ್ ಮಾಡೋದ್ರಾಗ ಏನು ಮಧ್ಯದಾಗ ಬರೋದ್ರಿಂದ ದಟ್ ಈಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಆಸ್ ಎ ಇಫ್ಲುಯೆಂಟ್. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೋ ಇಫ್ಲುಯೆಂಟ್ಸ್. ರೈಟ್, ಸಿ ಹಿಯರ್ all these solids that settle from the primary sludge ಅಂತಂದ್ರೆ ಏನಂತಂದಾಗ ಏನು ಕೆಳಗಡೆ ಕೂತಿರ್ತೀವಿ ಮಡ್ ರಾಡಿ ಅಥವಾ ಸಣ್ಣ ಪೆಬಲ್ಸ್ ಎಲ್ಲ ಕೂತಿರ್ತಾವಲ್ಲ ಅದ್ರ ಮೇಲೆ ಏನು ಉಳಿದಿರ್ತೈತಿ, ದಟ್ ಸೂಪರ್ನೆಂಟೆಡ್ ಅಂದ್ರೆ ಮೇಲ್ಗಡೆ ಕೆಮಿಸ್ಟ್ರಿ ಕಲ್ತಿರ್ಬೇಕು ನೋಡ್ರಿ. ಸೂಪರ್ನೆಂಟೆಡ್ ಇರ್ತೈತಿ, ಕೆಳಗಡೆ ಏನಂತ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅನ್ನೋದು ಕಲ್ತಿರ್ಬೇಕು. ಓಕೆ, ಹಂಗ ಏನಾಗಿರ್ತೈತಿ, ಆ ಸ್ಲಡ್ಜ್ ವಾಟರ್ ಏನಪ್ಪಾ ಅಂತಂದಾಗ ಕೆಳಗಡೆ ಮಡ್ ಸಣ್ಣ ಸಣ್ಣ ಕಲ್ಲೆಲ್ಲ ಕೆಳಗೆ ಸೆಟ್ಲ್ ಆಗಿರ್ತಾವ, ಅದ್ರ ಮೇಲೆ ತಿಳಿ ಏನಂತ ತಿಳಿ ಏನು ಬರ್ತೈತಿ ಸೂಪರ್ನೆಂಟೆಡ್, that we are going to call as a effluent. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೋ effluent ಅಂತ ಕರೀತಾರೋ. ಅಂಡರ್ಸ್ಟುಡ್? ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೋ effluent ಅಂತ ಕರೀತಾರೋ. ನಾ ಇಲ್ಲಿ ತನಕ ಆದ್ರಿಂದ ಏನಪ್ಪಾ ಅಂತಂದಾಗ ಪ್ರೈಮರಿ ಟ್ರೀಟ್ಮೆಂಟ್ ನಾಗ ಏನು ಮಾಡ್ತೀವಿ ನಾವು, in primary treatment we are going to remove the floating solid particle with the help of filtration and what grit, soil and small pebbles with the help of sedimentation, and whatever the remaining supernatant is there, that remaining supernatant is called as a effluent. That remaining supernatant is called as a effluent. And this effluent now we are going to pass from primary tank to the secondary treatment. ಈ primary tank ನಾಗಿತ್ತು ಅಲ್ಲಿ ನಾವು effluent ಏನು ಮಾಡೋದಿರ್ತಂದಾಗ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಅಂದಾಗ we are going to send that into the secondary treatment. ಈಗ ನೋಡಿ for example I am going to draw a small thing here. ಇದು ಏನಂತ ತಿಳ್ಕೊಳ್ಳೋಣ ಈಗ primary tank ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. primary tank ನಾವು sewage ಆಡ್ ಮಾಡಬೇಕು. sewage ಬಂತು sewage ಬಂದಾಗ ಏನು ಮಾಡಬೇಕು ಅಂದಾಗ ಈ floating debris ನಾವು through the filtration remove ಮಾಡಿದ್ರು. ನಂತರ sedimentation ಅಂತಂದಾಗ ಏನಿದೆ, this is GRIT grit head. ಓಕೆ, ಸೊ ಇದು grit ಆಯ್ತು. ನಂತರ floating debris ನಾವು remove ಮಾಡಿದ್ರು. ಇಲ್ಲಿ ನಡವಳಿಕೆ ಉಳಿಯೋಲ್ಲ supernatant, that is what effluent. That is what effluent. Then this effluent we are going to pass into secondary treatment. Pass of the secondary treatment. ಆಗ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಈ supernatant ನ secondary treatment ಸಲುವಾಗಿ ಪಾಸ್ ಮಾಡ್ತೀವಿ. Understood? ಅರ್ಥ ಆಯ್ತಾ ಈಗ? What I drawn on the board, sewage water ಹಾಕಿದಾಗ ಮೇಲ್ಗಡೆ ಫ್ಲೋಟಿಂಗ್ ಏನದಾವು ಫಿಲ್ಟ್ರೇಷನ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಿದ್ದು, ಕೆಳಗಡೆ ಸ್ಲಜ್ GIRT ಗ್ರೀಟ್ ಅಂತ ಬರ್ತೀನಿ, ಅದನ್ನು ಕೆಳಗಡೆ ಕೊಟ್ಟದ್ದು ಏನೋ ಮಾಡಿಗಿಂತ ಇತ್ತು. ಆನಂತರ ಈ ಸೂಪರ್ನೆಂಟ್ ಉಳಿದು that we are going to pass into the secondary treatment. So that's what I will get influence from primary tank to the secondary tank. ಅರ್ಥ ಆಯ್ತಾ? So this is the first primary treatment. Why I am telling you it clear cut tank ಆದಾಗ this question is going to arise for the 5 marks. You used to write step by step. Okay, next secondary treatment, or we are going to call it as a biological treatment ಅಂತ ಕರೀತೀವಿ. Secondary treatment or a biological treatment. Here what is going to happen, this effluent it is entered into the what we are going to call it as a large aeration tanks. Okay, the primary effluents passed into large aeration tanks. Large aeration tanks ಅಂತಂದಾಗಲ್ಲಿ the tanks build ಮಾಡಿದ್ರು. ಆ ಟ್ಯಾಂಕ್ಸ್ ಅನ್ನು ಹಾಕಿದಾಗ aeration ಆಗಿರ್ತದೆ. ಆ aeration that is helpful for the growth of various useful microbes. ಆ ಟ್ಯಾಂಕ್ ನಾಗ ಏನಿರ್ತಾವಪ್ಪ ಅಂದಾಗ ಬಹಳಷ್ಟು ಯೂಸ್ಫುಲ್ ಮೈಕ್ರೋಬ್ಸ್ ಇರ್ತಾವೆ that can use for what treating or a sewage treatment, purification of water, and those microbes they are going to call as a flocs. FLOCs. Now one last question is going to arise, what is mean by flocs? Flocs are ಏನು? Flocs are nothing but masses ಅಂದ್ರೆ ಬಹಳಷ್ಟು ಪ್ರಮಾಣದ ಒಂದು group. Masses of bacteria are associated with the fungal filament. Masses of bacteria are associated with the fungal filament to form mesh-like structure. Fungal filament to form mesh-like structure is called as flocs, or are called as a flocs. Understood? Now, once the flocs are going to develop, while growing these microbes, when the microbes are going to grow in a aeration tank the microbes will grow and start to that time they are going to consume in the sense they used to eat or they are going to consume the major part of the organic matter in the nutrients. In the sense sewage water the organic matter that organic matter they used to start consuming. And that what consuming the organic matter from the effluent that significantly reduces the BOD. Here BOD in the sense biochemical oxygen demand. In the sense what, if suppose this is a container of water and BOD, biological oxygen demand, if it is more, biological oxygen demand is more, that time this water is more polluted. Water pollution bhal irutade. If the BOD is less, that is the pure water. In the sense, suppose the organic matter create one of the microbes organic matter tinakatondre that reduces the BOD. BOD reduces the water purification ಆಗಿರುತ್ತೆ. Now what is mean by BOD in the sense? What mean by BOD in the sense, what we are going to call that as a, suppose 1 liter of water, 1 liter of water are the organic matter. The total amount of oxygen it is consumed by, total amount of oxygen it is consumed by organic matter, in a 1 liter of water, in a 1 liter of water with what we are going to call it as a 1 liter of water where oxidized means where oxidized the bacteria, oxidized by the bacteria. In the sense 1 liter of water is 1 liter water daga bacteria oxidized andrena bacteria oxygen release ಮಾಡಿದ್ರು ಅಲ್ಲಿ ನಾ ಏನು ಮಾಡ್ತಿದ್ದಾಗ 1 liter of water daga the organic matter ಏನಿರ್ತಾವಲ್ಲ ಅಂದ್ರೆ pollutant pathogenic they used to use the oxygen from that 1 liter of water. ಆ 1 liter of water ಇಂದ oxygen ನಾವು ಏನು ಮಾಡಿದ್ವು ಕನ್ಸ್ಯೂಮ್ ಮಾಡಿದ್ವು. ಓಕೆ ಹಾಗೇನಾಗಿರ್ತೈತಿ just organic matter ಇರ್ತೈತಿ ಅಷ್ಟಲ್ಲಿ ಏನಾಗಿರ್ತೈತಿ ಅಂದಾಗ ಆಕ್ಸಿಜನ್ ಲೆವೆಲ್ ಕಡಿಮೆ ಇರ್ತೈತಿ. organic matter ಎಷ್ಟು ಕಡಿಮೆ ಇರ್ತೈತಿ ಆ ಆಕ್ಸಿಜನ್ ಲೆವೆಲ್ ಹೆಚ್ಚಾಗಿರ್ತೈತಿ. Understood? So this is what BOD in the sense what I am going to read here. BOD is refers to the amount of oxygen that would be consumed by what organic matter in a 1 liter of water where oxidized by the bacteria. In the sense, if in a sewage the BOD demand means BOD biological oxygen demand is more, the water is more pollutant. Biological oxygen demand, biological oxygen demand is less, water is less polluted. In the sense, here what is going to happen? These useful microbes are going to consume the organic matter, If the organic matter is less in a sewage water or any water, that time what is going to happen? This biological oxygen demand is goes on reducing. ಈ ರೀತಿ ಏನು ಮಾಡಬೇಕು ಅಂತಂದಾಗ here in second treatment we used to go for the and this biological oxygen demand is measured. Okay, biological oxygen demand is measured of the organic matter present in a water. Organic matter is present in a matter. If the organic matter is present in water is more, biological oxygen demand is more. Organic matter is less in a water, biological oxygen demand is less. At that time you come to know whether the water is polluted or not. Understood? So here the greater biological oxygen means biochemical oxygen demand of wastewater, the more its polluting potential. In the sense, if the biochemical oxygen demand is more, water is more polluted. So in here, in secondary treatment, we used to go on treating that water with the useful microbes in an aeration tank, and we used to go on reducing the biological oxygen demand. And when this biological oxygen demand goes down significantly or reduced significantly, that time this influent from the secondary treatment or a biological treatment plant or a flux were allowed to sediment. And next, after this we used to pass this effluent to the next tank. After the secondary treatment, we are going to pass that what we are going to call that as a sewage water into the next. Okay, so what I told you, the treatment of sewage water primary, then we are pass that into the whatever effluents is there, that is passed into the secondary treatment. In the sense, in primary treatment what we did, filtration and sedimentation, then we are pass that water into this is what secondary tank we are going to make the secondary treatment or a biological treatment. And in this particular tank, what are there? The probes, in the sense useful microbes are there. They are going to consume the organic matter, and what they used to do after they consuming organic matter, the BOD biochemical oxygen demand goes on reducing, and once the biological oxygen demand is significantly reduced, that time what is going to happen in a secondary or a biological treatment only? From this tank, the water is transferred into the large tanks, and those large tanks are called as an anaerobic sludge digester. And in that particular tank, in the first tank, microbes and bacteria are going to consume the organic matter. Okay, and here when I want to pass this water after reducing the BOD ಕಡಿಮೆ ಆಗನ ಇದನ್ನ ವಾಟರ್ ಏನು ಪಾಸ್ ಮಾಡ್ತೀವಿ anaerobic sludge digester ದಾಗ ಪಾಸ್ ಮಾಡ್ತೀವಿ. and this tank also commanded the secondary of biological treatment. and in this particular treatment, okay, what here say if flows is like this flows are allowed to sediment and activated sludge, allowed to sediment in the sense this flow are allowed to sediment first in the sense ಈ flows ಎಲ್ಲ ಏನಾಗ್ತಪ್ಪ ಅಂದಾಗ ಕೆಳಗಡೆ ಬಂದಿದೆ ಕೊಡ್ತು like this. the flows are allowed to sediment here flows. okay, then whatever the water is there upside, that is significantly reducing the BOD, after the significantly BOD negativity reduce ಆಗಿರುತ್ತೆ, that water is transferred into the anaerobic sludge digester tank. and small amount of this water flows is again enter into the primary pack activated sludge. and activated sludge ಅಂತ ಕರೀತಾರೆ. small part of this pumped into the secondary tank for the inoculation. secondary tank ನಾಗ inoculation in the sense ಮತ್ತೆ ಅವು ಹೆಚ್ಚಿಗೆ ಗ್ರೋತ್ ಆಗ್ತದೆ. ಮತ್ತೆ ಇಲ್ಲಿ ಸಿರಿಜ್ ವಾಟರ್ ಬರ್ತಂದ್ರೆ ಮತ್ತೆ ಗ್ರೋತ್ ಆಗ್ತದೆ. ಹಾಗಾಗಿ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಏನು ಮಾಡೋದು ಪಂಪ್ ಬ್ಯಾಕ್ ಮಾಡೋದು ಇಲ್ಲಿಂದ ಆಮೇಲೆ ಎಲ್ಲ ಏನು ಹೋಗುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಟ್ಯಾಂಕ್ ನಾಗ ಹೋಗ್ತೀವಿ. ಈ ನೆಕ್ಸ್ಟ್ ಟ್ಯಾಂಕ್ ನಾಗ ಏನಿರುತ್ತೆ anaerobic sludge digester. anaerobic sludge digester ಅಂದ್ರೆ ಏನ there are other kinds of bacteria those can grow anaerobically in the sense without oxygen. they can grow without oxygen. and here these anaerobically bacteria are digest whatever their flows are there in a secondary tank nagittanta flows nella ಏನು ಮಾಡ್ತಾವ digest ಮಾಡ್ತಾವು. and during the digestion they are going to release methane, hydrogen sulfide and carbon dioxide. these are the three gases which are we are going to call them as biogas gases. and these all are what inflammable in the sense ನಾವು ಜ್ವಲನಶೀಲ ಇರ್ತವೆ. ಹಾಗಾಗಿ ನಾವು ಏನು ಮಾಡಬೇಕಪ್ಪ ಅಂತಂದಾಗ ಬೇರೆ ಬೇರೆ ಯೂಸ್ ಮಾಡಬಹುದು. ಅಂದ್ರೆ ಬಯೋಗ್ಯಾಸ್ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅದೇ ರೀತಿ ಯೂಸ್ ಮಾಡಬಹುದು. ಆಫ್ಟರ್ ದಿಸ್ the water can release into the what we are going to call it as a natural water bodies. now simply I used to tell you how we are going to treat the sewage water in the sense there are the two stages. one is primary treatment, secondary treatment it is called as a biological treatment. in primary treatment we are going to remove the floating solid particles small and large with the help of filtration and sedimentation that green or a soil or pebbles which are settled down with the help of sedimentation. after that water is passed into the secondary biological treatment plant or a tanks. and there two kinds of different tanks are there. one first tank which is consist of the microbes, the large number of microbes, useful microbes. and what I told you we are going to call them as a flows are nothing but what the bacteria associated with the fungal filament to form a mesh like structure. and these flows are going to start consuming the organic matter which is present in a sludge and it is helpful for the reduction of a biochemical oxygen demand. and once the significantly reduce the biological oxygen demand, that time what we are going to go for this flow or flow containing water is transferred into the other larger tanks. those are called as a anaerobic sludge digester. and there what is going to happen, these anaerobic bacteria are going to digest this flow and remove them from the water. and during that process they are going to release methane, hydrogen sulfide and carbon dioxide. these are the major biogas gases and those are used usually source of energy as it is impliable. then we are going to release that sewage water into the natural water bodies. likewise we used to write stepwise. if you are going to write in a sentences or else we are going to write in a what we are going to call it as a graphical representation. primary treatment, secondary treatment and aerobic sludges. then you are going to release those sewage water into the natural water bodies. okay, this much regarding the microbes in sewage treatment. after that we are going to study some what Ganga action plan and Yamuna action plan, in the sense in India they are what we are called, the Ministry of Environment and Forest has initiated Ganga action plan and Yamuna action plan, in the sense purifying the Ganga river water and Yamuna river water with the help of this microbial sewage, what we are called as a microbial sewage treatment. That is we used to discuss in a next class or in online class. Online class now discuss model. Before that, we used to remember these things. The microbial sewage water treatment, in the sense sewage water is treated in 2 stages. One is primary treatment and second one is secondary treatment or a biological treatment. And these are the steps involved in the sewage water treatment. I will continue next.